So, good afternoon, everyone. I'm starting to compete with the lunchtime. So I hope you will not be very much bored with my presentation. So, like Luisa said, I'm an assistant professor at the Department of Mechanical Engineering of the University of Aveiro, and I'm the coordinator of the Transportation Technology research group of our research unit, which is the Center for Mechanical Technology and Automation. So these are our 4 research lines, the topics in which we work. And in the second research line on ITS, we have 3 ongoing projects. So CISMOB, we are the coordinators, CRUISE, that I will talk about, and MobiWise, in which my colleague Miguel Luis from IT will talk about. So my fellow colleagues, namely Professor Carlos Borrego, already saved some of my time, so I thank you for that. So all of us know the impacts of transportation, namely on greenhouse gases, but not only that, on pollutant emissions that are nocive for our human health. Also, road safety is important, noise impacts, and we all know that even with the electrification, the electric vehicles, we will have conventional fuels to remain predominant over the next decades. So it's really a question of, there is also the need to optimize the use of the road infrastructure, and that's where the CRUISE project is all about. So the challenges and opportunities that we noticed in the beginning when we started working on this, it would be interesting to know what are the traffic congestion and emission hotspots, what are the most critical links in terms of congestion, where should we reduce pollution, but also what are the most vulnerable areas. So I can have higher emissions in one area, but if I don't have people over there, pedestrians or residents, maybe it's not so relevant if I am in a very much occupied area. In another hand, there is an increasing availability of data. All of us have our smartphones, and the smartphones are also data receivers and can be data transmitters of data. Then we have GPS, namely we can install GPS in different kinds of vehicles. Also, we can know the cell phone density, and of course we have the traditional traffic road monitoring network. So this was the background, the basis for the CRUISE project, that stands for Advanced Impact Integration Platform for Cooperative Road Use. It is an FCT-funded project together with Portugal 2020. It's a 2.5 year project, so it started in 2016 and it will end at the end of this year, 2018. So we are the coordinators in the Center for Mechanical Technology and Automation, but as Professor Borrego said, his group from the Center of Environmental Studies is also one of the partners, and also the colleagues of the Institute of Telecommunications in Aveiro. So what we are facing is, of course, transport is multidisciplinary, but the need in the research projects to have this multidisciplinarity, so to have mechanical engineers, transportation, environmental engineers, but also our colleagues from the information and telecommunication technology, is of utmost importance to have this research done. So the main goal is to integrate different road traffic impacts in a single platform. As my colleague Professor Borrego said, we had a previous project, Smart Decision, that was really focused on route choice impacts on emissions. So what is the best route to decrease CO2 or particulate emissions? But here we want to go a little bit further ahead. We want to integrate different impacts, not only emissions, but also road safety, noise, and traffic congestion itself. So at the end of the day, what we want to know is to assign a link-based indicator that integrates these different traffic-related externalities and also assess different contexts of vulnerability, so less dense areas and higher dense areas. In this project, we also have the international expertise of 2 institutions. So North Carolina State University, in the beginning of the afternoon, you will hear Professor Negri Rafael from this university, but also the University of Salerno for the noise part. So these are the tasks of the project. So first, we have to start by looking at the state of the art in the area. We already made and will be doing soon, again, some experimental work. So we need to know in the field some variables and to measure these variables. Then we will use traffic emissions, road safety, noise, and air quality models. So this is the third task. Then we will join everything in a single echo indicator. Through all projects, we are doing some data fusion and data management. And at the end, we want to establish network optimization and to design and establish this prototype, in order to have an integrated decision support system to be used for example, a decision support traffic manager. So just to give you a brief overview on the methodology, so as I said, we want to do some experimental measurements, namely through a radio frequency equipment. Our colleagues from IT are trying to detect the number of people in a certain area, namely through our mobile phones signals, so how many mobile phones are present in a certain area. Also, they developed a mobile application to collect data from different sensors and send them automatically to a server. We are installing GPS, as you can see here, in several vehicles. Also onboard diagnosis system inside the vehicle, so we can know the speed, acceleration, second by second along a different trip. We are also measuring along the road noise levels. 1 month ago, we received this equipment, which is a portable emission monitoring system. So this is an example of some measurements that we already made. So we can measure real-world emissions second by second along with the speed. We can measure, as I said, second by second emissions of CO2, NO, NO2, and also particulate matter. So this is very important. So these are not laboratory emission measurements. This is trying to assess the real-world emissions that a vehicle is doing. We use also some traffic models, namely VSIM, in order to know how vehicles behave on the roads under different circumstances. Then we have emissions, noise models, namely the noise model of our colleagues from the University of Salerno, air quality models, namely URBER and VADIS by our colleagues from the Environmental Department, and finally the safety model. And to join everything, we use some multi-objective methodology, namely this fast non-dominated sorting genetic algorithm. So I would like to present some of the results that we already achieved. Namely, we want to correlate traffic variables and emissions, and we know from our measurements and modeling that especially on urban links, the knowledge on travel time helps to anticipate emissions very well. Also, we correlated aggregated vehicle-specific power, so the load that I'm giving on the engine of the vehicle, we can correlate this with congestion algorithms and CO2 emissions, and this gives us a sense on the relationship between driving behavior and emission impact. So driving behavior is really one of the most important factors to characterize arterial routes. Okay, in the common sense we know that, but we are doing the quantification of this correlation. Then we have to, and we are calculating the impacts separately. So basically we have noise impacts, as you see on the left. We have, for example, CO2 impacts. This is Aveiro in all of these maps. We are establishing a GIS-based modeling structure with all this data, and we are turning everything into costs then in order to join everything in a echo indicator. Our colleagues from the Environmental Department, like Professor Borrego showed, are calculating the concentration fields. Then how to integrate everything? So we made already some route choice impacts, namely the impacts on pedestrians and residents of a different area. So we identify already some trade-offs in the minimization of these environmental indicators. There is an obvious conflict between the minimization of environmental costs and the exposed population to these local traffic externalities. We are worried not only on the route, so a more macro level, but also on traffic singularities themselves. So for example, roundabouts, that's one topic that really attracts us a lot. So how to make multi-criteria assessment on a corridor with different roundabouts. For example, in this case, we were interested to know what is the best location of the crosswalk next to a roundabout. So what we find out, and in order to weight basically the pedestrian travel time, the vehicle delay, the emissions, but also the noise criteria. So what we figured out is that in this case, the crosswalk that is in this location, about 33 meters of the roundabout, achieved a good balance among the traffic and pedestrian performance, emissions and noise. But the noise criteria itself dictated some other optimal locations, namely between 13 and 23 meters from the exit of this roundabout. So we are also doing some scenarios along corridors of roundabouts. For example, here we are evaluating the corridor operations in these different dimensions and doing scenarios to establish, for example, partial metering-based strategies. For those that are not familiar with this term, partial metering is basically to install traffic lights close to roundabouts. So can we improve the traffic performance close to roundabouts with this installation of traffic lights? And using the metering system, we really had overall costs, so travel costs, emission costs, noise, that can decrease up to 11% compared with the normal roundabouts performance. In this project, we are not only worried and concerned with motor vehicles performance, but also vulnerable road users, namely bicycles. So we installed an onboard platform of sensors in a bicycle. So basically we have sensors of speed, acceleration, and distance. And by using also a smartphone application, we want to communicate, for example, the distance from a motor vehicle to the bicycle in order to give the sense to the cyclists if the motor vehicle that comes ahead and that is passing the bicycle is in a safer distance or not. So if the motor vehicle is in a distance less than 1 meter, it gives a red color. If it goes, oh, I don't know what happened. Okay, the meeting ended. Fine. So what I'm saying is that, for example, according to the Portuguese road code, the motor vehicles have to give at least 1.5 meters of distance when they are passing a bicycle. So if the motor vehicle is in a safer distance, it gives to the cyclist a green color. Because one of the arguments that people have to not bike more, it's really the question of safety along the road. So this is also a question that we want to assess. On the other hand, we are assessing crashes involving pedestrians and cyclists, and the National Agency for Road Safety gave us real data crashes, about 4,500 crashes involving vulnerable road users in 3 cities of Portugal, Aveiro, Lisbon, and Oporto. From these, we have 4,600 injured bicyclists, cyclists, and pedestrians. Fortunately, the big majority, more than 90%, are light injured, and from this number, 87% are pedestrians and 13% are cyclists. So we are doing some spatial information. We are also analyzing the time information. So what is the day in which the crash occurred, day of the week, the hour, what is the luminosity, the light situation, namely because of the weather conditions, and we are doing some multinomial logistic logistic regressions using statistical softwares. So, as I said, we made some special analyses in the 3 cities. We concluded that most crashes occur in high attraction places, like rail stations and close to malls, so with speed limits under 50 kilometers per hour. And that significant predictor variables are, for example, the vulnerable road user, gender and age, as well as weather conditions. Again, on vulnerable road users, we want to assess the different impacts, so basically the safety impact, the emissions along the route, also the travel time, and to weight all these dimensions in a multi-criteria methodology. So to conclude my presentation, I think all of this was already done, or was already said. So we have the importance of the technology, namely ITS, installed on vehicles, installed on the road infrastructure, but it's a question also of behavioral change of the drivers of motor vehicles, the cyclists, the pedestrians. So all this synergy together with the multi-criteria evaluation of the different impacts leads, in my opinion, to more sustainable mobility. So thank you very much for your attention, and of course thank you to my funding agencies. Thank you very much.